Okay, so last time we had the discussion about strong acid, strong base titration, as well as its counterpart, yung strong base, strong acid titration. Okay, and balikan lang natin yung mga sinabi ko that time. So skip na natin yung mga parts na yan. So it's important for you to know that there are four stages in a titration process, namely the initial stage, the pre-equivalence stage, equivalence point, and then the post-equivalence point. No? So, first stage, iba-iba yung equation. Why? Kasi iba-iba yung species present no, in that region. Okay? When you do the titration. Kaya iba-iba yung equation. However, kung alam mo naman yung species na present, then actually kahit di mo kabisaduhin yan, magkakaroon ka ng idea how will you formulate your own equations, di ba? Okay, so yan. So for strong acid, strong base titration, of course, you begin with the strong acid. So this will determine the pH of your solution. So that's why whatever the concentration of the acid is, yun yung ginagamit natin for the pH. Okay? But when you add your base, your titrant, no, nababawasan na yung concentration ng acid. So we use this equation. This part accounts for the reaction between your acid and the base. And then the volume total here is used to infer that the solution is being diluted kasi nag-add up yung kanilang volumes. And for equivalence point, your acids and base will become neutralized and you will form salt and water. Okay. The water here is the one that will predict the pH of the solution, which is if neutral, 7 yan. No? So the equivalence point here is 7. And for the post-equivalence point, you have an excess base. So mas maraming titrant kaysa sa analyte. Okay. At same story is true for eto. Okay, so same story is true for the SBSA, no? But baliktad lang, no? So you begin with your base, okay? You have your metal hydroxide here. So you use that to get the POH and then eventually get the pH, no? And then as you add your titrant, which is an acid this time, okay? Habang dinadagdag yung titrant, nababawasan yung base. So we use this formula to see gaano karami yung base na yung natitira. And again, at the equivalence point, everything will be neutralized. So it's just the water that will predict the pH of the solution, which is 7. And then finally, at the post-equivalence point, you have too much acids naman. Okay? So for strong acid, strong base titration, strong base, strong acid titration, the equations are very related to each other. No? And it's pretty straightforward naman. Okay. Now, I want to go dito na sa next part natin. No? So let's try to finish everything in this video. So here, we have the monoprotic weak acid strong base titration. No? So again, just like sinabi ko before the Holy Week break, atong WA, it means ito yung analyte. Kung ano yung una, yun yung analyte. And ito yung titrant. No? Okay. So I have your analyte as the weak acid and the strong base as your titrant. Remember yung sinabi ko last time that we cannot use a weak acid or a weak base as a titrant. No? Bawal yun because the reaction won't be complete. No? Ang requirement for a titrant kasi is complete yung reaction niya. Okay, so analyte lang talaga yung weak acid or weak base. No? Okay. Now, what do we know about weak acid strong base titration? No? So weak acids, no? Pag nilagyan mo yan ng let's say gawa tayo ng equation. Pare, this is HA, weak acid, then maglagay tayo ng sodium hydroxide which is a strong base. They will be neutralized, no? So you will have your sodium A, an ion plus water. Okay? Ganito yung nangyayari as you add your titrant, no? However, ano pa yung special with weak acids, no? or weak base din. Ano yung special sa kanila? 'Di ba ito yung acid niya, okay? According to the according to the ano, tawag dun, according to the Bronzed-Lowry definition, okay. Nag-Holy Week break yung utak ko. So according to the Bronzed-Lowry definition, 'di ba you have your weak acid dito. Pagdating sa product side, may counterpart siya, no? Ano tawag dito? Conjugate base, no? O kung ito naman, weak base to, tawag doon, conjugate acid, no? So ibig sabihin there's a mixture of a weak base or a weak acid and a conjugate, no? So ano tawag natin doon? Buffer, 'di ba? Okay, so that's why medyo kakaiba yung equations natin this time. Okay, so tignan mo yan, ang gulo-gulo ng equations, 'di ba? Okay, anyway. So yan, now, okay, so like usual, we still have 4 stages when we do our weak acid strong base titration. You have your initial, pre-equivalence, equivalence, and the post-equivalence. No? And then at each stage, iba-iba yung species present. That means also iba-iba din yung equation, no, for each stages. No? So now let's try to rationalize on bakit ganun yung equations, no? Because it's really different, no? Okay. So umpisa tayo dito sa initial stage, no? So sa initial stage, ano meron sa system mo? You just have the water and your acid, no? Okay. So of the two, sino yung magko-contribute sa pH? Well, of course, it's the acid, no? Okay. However, this is a weak acid, no? So what I mean by that is when you have a certain concentration of your weak acid, di ba it doesn't fully dissociate, no? So therefore, if you want to get how much protons are there, no, in the solution, you must use the ice table. Okay? Papaalala ko lang uli yung mga ginagawa natin dito before. By your acid, it will form equilibrium to these products. Okay? Ito yung kailangan mo to get the pH. Eh. So what do? You make your ice, no? So kunwari ito 0.5, 0, 0, plus x, minus x, etc. Diba you do that? No? But we have a shortcut, no? Para dyan. Ano yung shortcut natin? If you want to get the concentration of the proton coming from your weak acid, our equation is the square root of tsaka. Saan galing to? This came from the small x approximation. No? Diyan yan ang galing. No? Small x approximation. Square root of tsaka. Okay? Wherein the CHA is the concentration of your acid. The Ka is the acid constant. Okay? Acid dissociation constant. Okay? So, I guess, hindi pa naman siguro nakakalimutan yan. Okay. Now, let's go to the pre-equivalence point. No? At the pre-equivalence point, ano meron dito? At the pre-equivalence point, syempre, your original acid is being neutralized. No? Nababawasan na siya. So, it's neutralized by your base, the titrant. So, ibig sabihin, no, nababawasan na yung acid mo. It's less na. However, the neutralization of the weak acids produce or results in the formation of your conjugate base, di ba? So, may conjugate base kang mapoproduce. No? Ngayon, ano meron? If you have a weak acid, you have a conjugate base, then that means you have a buffer solution. Okay, so that's why as you can see, ito medyo familiar to. This is buffer. No? So pH equals pKa plus log conjugate base over the acid. No? However, hindi natin alam how will we determine the conjugate base? No? How will we determine the acid concentration? Okay, so ngayon, mag-ano tayo? Ngayon mag-ano tayo? Isip paano natin kukunin yung concentrations nila. Okay. O ngayon, ano alam natin? The acids are decreasing because you added your titrant. No? So sa tingin mo, ano yung pwede equation dito? To get the concentration of the acid, that can be ano na lang, or the amount of the acid. By the way, gagawin ko na lang moles to kasi mas mabilis yung moles. No? So to get the amount of the acid, that's moles of the acid minus the moles of the base added. Ano yung acid mo? Analyte. So yan ay MAVA minus ano yung moles ng base? Titrant, no? MTBT. So it's MAVA minus MTBT sa denominator. Okay, so ganun lang kasimple. No? So acid minus the base kasi mas maraming acid. So the equation here will be MAVA minus MTBT. So that will give you the moles of the acid. Now let's go here naman sa taas. No? So this is the conjugate base. No? Paano natin kukunin yung amount niya? No? Paano kaya? So isip tayo, saan siya nanggaling? When did your conjugate base appear? When you added your titrant, di ba? So ibig sabihin, the amount of the titrant is related to the amount of the conjugate base. No? So ano yung amount ng titrant? So it's MTVT. Okay? Okay? So yun yung equation natin for that. No? The amount of the conjugate base comes from the titrant. And the amount of the titrant can be computed as MTVT. No? Meanwhile, the amount of the acid remaining is the difference between the original acid minus the base. No? So MAVA minus MTVT. Okay, so very simple na. Ayan. So tandaan nyo na lang ito. Burahin ko na ito, nasa baba na ito. Okay, so ayan. So it's MAVA minus MTVT sa denominator, MTVT sa taas. No? Ayan. Okay. So sabi ko sa inyo, kaya nyo gumawa ng equation as long as alam nyo kung saan sila nanggagaling. Sa titrant ba? Sa analyte ba? Sino mas marami? Ganun. Okay? So kailangan kaya nyo yun. Okay. So next one, equivalence point. No? So ano meron sa equivalence point? No? So sulat ko ulit equation ko kanina dito. So di ba you have your HA plus NaO. All of them has been converted to this, no? Water and the salt, no? However, itong salt na to is not just the typical salt, no? This contains the conjugate base, no? So it contains the conjugate base, no? So wala ka na niyan at the end of the reaction because all of them has been converted to conjugate base. And what do we know about conjugate base, no? Okay? Ano alam natin about conjugate base? Oh, yung A lang talaga yung conjugate base. So buburahin ko yung sodium. So you have your conjugate base. What do we know about this? This forms an equilibrium. HA plus OH minus. The fact that you produce OH means basic nga talaga si conjugate base. So ano implication nito? What can we infer to this? No? So since at the equivalence point, the species present is just water and the conjugate base. So the pH of water is 7. However, the presence of the conjugate base makes the solution basic. No? So when you have a weak acid strong base titrant, your equivalence point is probably greater than pH 7. So hindi na siya always 7, no? Katulad ng sinasabi ko last time. 7 na yan agad, no? Pag may nagkamali dyan, ewan ko na lang. Pero ngayon, hindi na siya 7, no? Why? Because of the presence of the conjugate base. When conjugate base joins with water, it produces the OH. No? What else? No? This is an equilibrium equation. Okay? So, therefore, we can apply the similar thing. Mag-ice table ka dyan. Okay? But eventually, you will get this equation. So, the concentration of OH equals the square root of conjugate base concentration times Kb. Hindi yan ima-minus. That's A minus, the charge of the ano lang, of the anion. Okay, so it's Ca times Kb. Okay? So, ganun. Saan galing to? Ano lang yan? Small x approximation. Okay? So, yun. So, ang important dito, lagi nyo tandaan that at the equivalence point, the pH is greater than 7. It's no longer 7. It's greater than that. So, isosolve mo siya. Okay? Now, well, paano natin kukunin yung concentration of the conjugate base? Saan ba galing uli yung conjugate base? Galing sa titrant. No? But again, this is equivalence point. Ibig sabihin, the amount of the titrant is equal to the amount of the analyte. No? So we have two equations here. So the concentration of the conjugate base can be computed as the moles of the analyte over the volume total, or it can be computed as the moles of the titrant over volume total. Okay, so it's either of the two. Why? Equivalence nga. No? Equal na yung amount ng analyte at ng titrant. Okay. So that's how you will get the concentration of the conjugate base. No? Now, how about the Kb? Well, madali lang yan. Di ba, you're given a Ka. So alam mo, when you multiply Ka and Kb, you will get Kw. Ano? Ayan, so Kw yan. So, ayun lang. So, just to get the Kb, edi plug in mo lang doon. So, divide Kw and Ka. That will give you the Kb. Okay? So, sige, pakita natin. So, Kb, Kw over Ka. Okay, so ganun lang. So, again, important tandaan that at the equivalence point, the pH is no longer 7. And then finally, at the post-equivalence point, you have three species present. You have the water, the conjugate base, and your excess strong base titrant. No? Okay? So I have to emphasize yung strong base. No? Why? Kasi sino ba yung mga pwede mag-contribute sa pH? Well, the pH of water is 7. Conjugate base is probably greater than 7. Okay? But the strong base is stronger than the conjugate base. So this will determine the pH of the solution. So gaano man karami yung base titrant that was added, siya yung magdedetermine ng pH ng solution. So how do you get the excess base? Well, same lang yan sa kanina. No? So it's MTVT minus MAVA over V total. Okay? Another way to do that is itong equation na to. So volume titrant minus volume titrant at the endpoint times molarity titrant over V total. So same lang din yan. Na. But siguro for ano na lang, for uniformity, let's use this equation instead. Okay. So again, bakit ito yung equation na ginamit natin? Ba't di tayo nag-equilibrium? Kasi the strong base is stronger than the conjugate base. So, ma-overpower niya yung equilibrium. So, wala tayong equilibrium. It's just stoichiometry. Okay? Yun. So, there you have it. Those are the equations for the monoprotic weak acid strong base titration. No? And siguro bago tayo pumunta sa mismong solving, I want to explain na muna yung weak base strong acid naman. So skip muna natin yung solving. Explain ko yung weak base strong acid para nakalista na lahat ng equation natin. And then mamaya sa dulo ng video, dun tayo magsasagot ng lahat. Okay? So let's skip that. Okay, sorry, before we skip, this is how the titration curve looks like, no, for a monoprotic acid-base titration of a weak acid strong base titration. So ayan, so weak acid strong base titration. Of course, you begin with a very low pH, malamang kasi you have an acid. So you begin with the low pH because you begin with a weak acid. But as you add your titrant, the strong base titrant, unti-unti aakyat yung pH na. However, what's remarkable here is ito. You see this region, okay? At this region, ang dami mong inad na titrant, but the changes in the pH is just 1 unit, no? Kunwari, ito pH 2, ito pH 3. You added a lot of titrant, pero the change in the pH is very minimal, no? So, tawag natin doon buffer region. Okay? So, that's your buffer region. Okay? Yun yung experiment number, experiment number 4, di ba? Despite gano'ng karami inad mo na sodium hydroxide or acid, still magkakaparehas lang yung pH niya, no? Yes, because as well for that's buffer region. It's governed by Henderson-Hasselbalch equation. But there will come a time that the buffer will be destroyed, masisira na yung kanyang buffer capacity, then it will come to an endpoint. Again, at the equivalence point, the pH is greater than 7. And then you have your post-equivalence point, no, wherein the strong base will or the excess strong base will determine the pH of the solution. Okay, so that's your titration curve for the weak acid strong base. And now let's proceed on the equations for the weak base strong acid titration naman. Okay, so here we are at the weak base strong acid titration. Again, we skip the calculation muna para tuloy-tuloy tayo later on. Okay, so let's explain all the equations first. So for weak base strong acid titration, so parang ito yung WASB kanina, baliktarin mo lang. So your weak base is your analyte and the strong acid is your titrant. No? Yeah. So it refers when you have your weak base analyte are titrated against strong acids. No? So still you have 4 stages like the usual, the initial, pre-equivalence, equivalence, and the post-equivalence. And the equations here are quite similar to the WASB kanina, no? So halos parehas lang din. Okay, so let's begin. No? So initially, you have your base and the water, no? The weak base, no? And what happens, no? When you have a base, it joins with water, form ka ng, ayan, no? You form hydroxide, no? Which is a base, no? So yan, i-ice table mo yan, and then apply small x approximation, you will come up with this one. No? So, parang ito yung square root of tsaka. Pero kapag base, di square root of CBKB naman. I guess you're quite familiar with this one. Sinabi ko yan ilang beses last time. Okay? So, yan. So, it's like the square root of tsaka, but base naman. So, it's CBKB. Okay? So, yan. So, small x approximation lang. But keep in mind, basic yan. So, you will get an OH concentration. So, pag ni-negative log mo yan, ibig sabihin nun, yan ay, POH. No? So, isusubtract mo pa yan sa 14 para makuha yung pH. Okay? And then we go to the pre-equivalence point. No? At the pre-equivalence point naman, so you have your base being neutralized by your acid. No? So kunwari your acid is HCl. So what will happen here? Yung base mo, it will be protonated. Okay? Yeah, so it will be protonated. So you have less of the base kasi na-neutralize na siya ng acid. And you have this presence of conjugate acid. No? And ano ulit sabi natin, kapag meron kang weak base conjugate acid, you have a buffer. No? Parang kanina lang, may buffer ka uli at the pre-equivalence point. No? So the buffer equation here will be the POH equals PKB plus log conjugate acid over base. No? Very analogous with the pH equals pKa plus log conjugate base over acid. No? Okay, so yun. So same lang halos except that POH yung makukuha mo kasi this is a base. No? How do you get the PKB? So ibibigay naman yung KB no? Sa problem, you just take the negative log. Now, how about the concentrations of the base and the conjugate acid now? So look, ang base mo nabawasan. So you have your base analyte nabawasan ng amount ng titrant, no? So ano sa tingin niyo yung equation para doon? Yung analyte nabawasan ng titrant. So it will be MAVA minus MTVT. Very similar sa kanina, no? Oh, now, how about the conjugate acid? Kailan siya nag-appear? When you added titrant. So, ibig sabihin, the amount of the conjugate acid is related kung gaano karaming titrant nilagay mo. So, ano equation doon? Yun ay MTVT. Very similar sa kanina. Okay? Now, punta naman tayo sa equivalence point. So, at the equivalence point, you have your, you don't have your base anymore pala, no? So, wala na to. Wala ka ng reactant. All you have are products. No? Okay, so you have your water and the conjugate acid. Now, let's focus on the conjugate acid. No? So, focus tayo kay conjugate acid. So your conjugate acid, it dissociates, of course, no? Into this. No? So when your conjugate acid dissociates, it produces proton. So that means the equivalence point pH here is probably less than 7. No? Okay, so it's less than 7. So unlike kanina greater than 7, ngayon less than 7 naman. Okay? So yun. So ngayon, how much yung H plus natin? How much yan? Well, you can do the ice table. Okay, pwede ka mag-ice table dyan. Plugin mo lahat. Then you do your small x approximation. And ang makukuha mo doon is parang square root of tsaka din. Okay. So parang square root of tsaka din yung makukuha mo. No? Ayan. So when you do the ice table yan, no? So lalabas yan very similar to the square root of tsaka. But the concentration here is not the acid, rather it's the conjugate acid. No? So concentration of conjugate acid times the Ka. Okay? And then, paano kinukuha yung Ka? Again, Ka-Kb equals Kw. So divide both sides by the Kb lang. And paano naman yung concentration of the conjugate acid, no? So we have two equations here, parang kanina lang din, no? We can use the moles of the acid over the V total or the moles of the titrant over the V total. Why? This is equivalence point. So ibig sabihin equal yung analyte, equal yung titrant. So either way, it will give you the same answer. Okay? So you can either use this equation or the other equation. And finally, you have the post-equivalence point. No? So the post-equivalence point, you added too much titrant, too much strong acid, no? So you have your three species here: the water, the weak, the conjugate acid, and the excess strong acid. Like kanina, okay, the excess strong acid will determine the pH of the solution. Therefore, the equation is ganito lang din. Okay? Parang kanina lang din talaga. So the excess titrant minus analyte over V total. But since you have the strong acid, it's H plus now. Kanina kasi, strong base yung excess. So OH yung nasa solvent. Now, it's acid naman. Okay, so it's H plus. Okay. So those are the rationale behind the equation. So yun yung 16 equations. Pero kung maaalala mo na maigi yung equilibrium ninyo, madali lang. Kahit hindi kayo bigyan ng kodigo, kaya nyo sagutan yung problem. No? Okay. So kahit walang kodigo, kaya nyo sagutan yung problem. Why? It can be inferred, no, by what species are present. Sino mas marami, sino mas konti. Okay? So, ganun. I hope that's how you think. Ano? Wag nyo kabisaduhin yan. The reason why I'm explaining this for half an hour already is para kaya nyo mag-derive on your own. Okay? But anyway, sa final exam naman, may list of equations kami bibigay. Okay? But yan. Okay, so that's it. No? Those are the equations, and let me just show you the titration curve for the weak-based strong acid. So baliktad naman dito. Kanina we started here, pag ganon, di ba? Now, pababa naman. So of course, initially you have your so strong acid, sorry. So initially you have your weak base, no? So it will have a very high pH, no? And then as you add your titrant, bababa yan, then you have your inflection point here. That's your equivalence point. And the post-equivalence is, of course, acidic. I want you to notice again this region, okay? So this very long region in which ang daming volume ng titrant yung nilagay, but the change in pH is 1 unit lang, no? So that's your buffer system, okay? So that's your buffer system, okay? And then suddenly, masisira na yung buffer, okay? Masisira yung buffer capacity, then you have your equivalence point. Okay, so those are the titration curve and the equations for weak acid strong base and weak base strong acid titration. Now, on the second part of this video, discuss ko naman how you can answer the problems related to this. Okay. Okay, so now let's proceed to the problem solving na. So you already know the equations. If may hindi kayo mag-get, sabihin nyo lang sa akin. Pero balikan nyo muna yung video na. Okay, so nalista na natin lahat ng equations kanina. And then now, it's our task to do this problem. Na. So sagutan natin lahat ng problems that we have here on hand. And then, tignan natin if okay yung titration curve natin. Okay, so let's begin with this one. So the problem states that you have 20 ml of 0.2 molar formic acid. The Ka is 1.8 times 10 raised to negative 4. And it was titrated against 0.1 molar sodium hydroxide. So kagaya ng sinasabi ko before Holy Week, yung unang binabanggit dyan is your analyte, no? And yung sumusunod na binabanggit dyan is your titrant. No? So, as you can see, for your analyte, the formic acid, given yung Ka. So that hints na ito ay weak acid. No? Weak acid analyte. No? And then for your titrant, it's sodium hydroxide, which you know is a strong base. No? So this is a strong base titrant. Okay. So what we have here is a weak acid strong base titration. Okay. So yeah, it's very important you identify the type of titration that you have here. Na, ayan. So ano pa? So ito yung amount ng volume titrant added. So ang daming volume. Hindi ko alam kung anong stage na ako. I don't know. Ano stage ng mga yan. So ano gagawin ko? What do you think? Ang una kong gagawin ay mag-determine ng endpoint. So let's determine the endpoint. What do we know about the endpoint? The moles of the acid is equivalent to the moles of the base. No? So equivalent yan. So mole of the acid, so that's your formic acid. So MAVA equals the mole of the base. No? So MT VP at endpoint. No? I'll call that VTEP, volume titrant at endpoint. So the stoichiometry is 1-to-1, monoprotic naman to. So let's solve for the VTEP na. Volume of titrant at the endpoint. So it will be MAVA over MT. So you have 20 ml, 0.2 molar divided by 0.1 molar. So ang sagot dito, 40 ml titrant. No? So the amount of titrant that's needed to neutralize your formic acid is 40 ml. No? Okay, so sige. So now, we identified that the 40 ml volume titrant is the endpoint. That means I can assign different stages na. No? So of course, yung 0 initial yan. And these are the pre-equivalence point. This is your post-equivalence point. No? Okay. And again, for each stage, iba-iba equation. No? So let me write the stage nga. Tingnan ko kung naalala ko pa. So for the initial, so square root of tsaka yan. Okay. Square root of tsaka lang yan. The pre-equivalence point, you have the buffer. Okay, so pH equals pKa plus log concentration of the conjugate base. Okay. Let's write it as HCOO minus over the acid HCOOH. Sorry. Yeah. At the equivalence point, ano equation ko dito? So that's OH equals, naalala ko lang, square root of the concentration of the conjugate base times Kb. No? And then at the post-equivalence point, it's just the concentration of your excess titrant. No? So it's MTBT minus MAVA over P total. Okay. So, yeah. So ganun dapat na. Kailangan alam nyo na yung equations at each stage. No? Anyway, pwede mo naman i-derive. No? Ako, personally, di ko sila kabisado. You just remember anong stage ka, ano yung possible equations doon. No? So, yeah. But it will take time for you to have a good grasp of this. No? So anyway, yan, solve na natin. So let me just use my calculator. Okay, so we have our calculator here. So sabi, at the initial stage, we just compute for the square root of tsaka. No? So that will give you the H plus. Pero I want the pH. So I'll type in negative log, okay, base 10, kaya may 10 sa baba. And the expression for the H plus, which is the square root of tsaka. And now, what's my concentration of the analyte? It's 0.2 molar. And the Ka is 1.8 times 10 raised to negative 4. So this is my initial pH. So the pH is 2.22. Okay, so let's write pH equals 2.22. Okay? So yan. So hindi ko na sulat yung solution dyan, no? So yun na yun eh. Square root of tsaka lang, no? Okay. And now, proceed tayo sa pre-equivalence, no? Ito susulat ko to para guided kayo. Okay, so at the pre-equivalence point, the equation again is the Henderson-Hasselbalch equation lang, no? So pH equals pKa plus log the concentration of the conjugate base over the acid, no? Okay. And then now, saan natin kukunan yung pKa? Sa Ka. You just take the negative log of that, no? So we can write it as the negative log of 1.8 times 10 minus 4. And then for this one, okay, so ayusin lang natin sulat. So plus log, okay, saan galing yung conjugate, saan galing yung conjugate base natin? Galing yan sa titrant, no? So when you say galing sa titrant, the expression is MTBT. That's the moles of the titrant. Ngayon, ano nangyari dito sa acid mo? Nabawasan. So initially, mas marami acid, tapos nabawasan yan no, ng titrant. No? So the expression here should be MAVA minus MTBT. Now, let's think. No? Ano yung isipin natin? Molarity titrant, 0.1 yan. So this should be 0.1. Volume titrant, well, iba-iba yan. No? So X, this is X, this is 0.1. Yung volume analyte, it's 20 ml. Molarity analyte, 0.2 molar. Then yung X, papalitan lang natin. No? Okay, so it's either the 15, the 20, the 35. No? Okay, so yan. So let me show you how it's plotted in your calculator. No? Okay. Let me share my phone again. Okay. So you have your negative log base 10 of 1.8 times 10 raised to negative 4. That's your Ka. Plus logarithm of base 10 of the MTBT, no? So gawin natin yung 15 ml. So 0.1 times 15 divided by the MAVA, 0.2 times 20 minus the MTBT, 0.1 times the 15. So it's 3.52. No? So 3.52 dito. Then let's replace yung 15 by 20. So let's replace the 15 by 20. So it's 3.74. Oops, yeah. Okay, so 3.74. And then lastly, yung 35 gawin natin. So palitan mo lang volume, 35. 35 equals sign 4.59. Okay, it's 4.59. Okay. Now, I want you to notice something cool dito. Okay. So, kunin nga natin yung pKa. So, pKa lang. Solve natin yung pKa. So, di ba pKa is negative log of Ka. So, 1.8 times 10 raised to negative 4. Negative log. Sorry. Ayan. So, ito pKa. Negative log na. Ano napansin nyo? Is there a point in your titration curve where the pH is equal to the pKa? Yes, no? And that is yung 20 ml, no? Okay. So at 20 ml, pH is equal to pKa. Or we can say na ano, no, at half the endpoint, pH is equal to pKa. And this is a special region, no? So special region yan. Kasi only at that point yan nangyayari, no? So, di ba ang endpoint natin 40? Ano kalahati nun? 20. And as you can see kanina, when you get the pKa, it's 3.74. It matched with this, no? Ngayon, so that's a special region, no? Kasi at that point lang nagiging equal sila. Special kasi, di mo na kailangan mag-solve na mahaba. Ayan. Okay. Ngayon, paano nangyayari doon? What happens? Bakit nagiging equal yung pH sa pKa? So let's try to plug in some values. So ano yon? 20, di ba? So etong part na to, isusulat natin dito. So it's 3.74 plus log of 0.1 times 20, 0.2 times 20, na 0.1 times 20. So ito lang din yun. Yung 3.74, yun na yung pKa dito. Okay? Tapos, ano yung 0.1 times 20? Di 2, di ba? So, 0.2 times 20, di 4. 0.1 times 20, di 2. 4 minus 2, 2. 2 over 2, 1. And what's the logarithm of 1? This is 0. No? So that means at half the endpoint, nag-zero out yung concentrations dito. No? Nagka-cancel out sila lahat. No? So you have an equal amounts of the conjugate base and the acid. No? So yun yung special region. You have an equal amount. Equal amount of the acid and the conjugate base. No? So yun, a weak acid and the conjugate base. Okay? So ganun. So kaya siya special region. Okay? And ito yung nasa pre-lab nyo. No? Dati. Okay? So ganun siya ka-special. Okay, so I'll proceed with the 40 ml na. So let's proceed dito sa equivalence point. So let me share the screen again. Okay, so yan. So the equivalence point naman, ito yung equation natin. OH equals square root of the concentration of the conjugate base times Kb. So let me erase everything muna dito. So erase ko lang tong pre-equivalence kasi wala na akong space. Okay, so at equivalence point, gawin natin yan. The OH concentration is equals to the square root of the conjugate base times the Kb na. Or let's write it as CA minus KB. Now, saan galing yung conjugate base? So, galing yan sa titrant. However, the amount of the conjugate base can also be obtained using the amount of the analyte. No? Okay? So, either way, pwedeng amount ng titrant, pwedeng amount ng analyte, yun yung gamitin natin. No? So, we can write it as the titrant na lang gagamitin ko just to be consistent. No? So, molarity titrant, volume titrant. Moles pa lang yan ng conjugate base. No? To make it concentration, we divide it by the volume total. Kasi moles over volume, concentration. Diba? So, molarity titrant, volume titrant over volume total. Times the Kb. So, how do you get the Kb again? It's Kw over Ka. So, let's plug in everything lang. No? So, let me, asan yung calculate? Okay. Sige, so let's plug in everything. So, OH, so that's square root of molarity titrant, 0.1, times volume titrant, 40, over the volume total. So, what's the volume total? You have 40 ml of the titrant plus 20 ml of the analyte, diba? So, yan yung volume total. Times Kw. What's Kw? 1 times 10 raised to negative 14. Ano yung Ka? 1.8 times 10 raised to negative 4. Negative 4. Okay? So, yeah. So again, this is your molarity titrant, volume total. So you have 28 ml of the analyte, 40 ml of the titrant. Then this is your Kw over Ka to get the Kb. Okay? So let's press equal sign. Ano to? This is OH. So let's take the negative log. We get the, we get the POH, 5.72. Eh gusto ko pH. So anong gagawin ko? It's 14 minus the POH. So 8.28 ang sagot dito. And that proves our idea kanina, no? So that proves our idea kanina kasi anong sabi ko kanina na at the equivalence point when you neutralize your weak acid, your pH is greater than 7. Why? Because of the influence of your conjugate base. Okay? It's because of the influence of this conjugate base na to. And now at the post-equivalence point, well, yun na yung equation. And ipa-plug in ko na lang sa calcu ko. Ha? So, let's put it directly sa calcu. Post-equivalence point. So, for the post-equivalence point, well, it's just OH yan eh. Gusto ko pag pinindot ko equal sign ko pH agad. No? So, it's 14 minus the POH, which is negative log. Okay, so MTVT minus MAVA over V total. MT times volume total of 55 ml gawin natin. Minus MAVA, 20 times 0.2 divided by the volume total. So 55 yung titrant, 20 yung analyte. So when I press this equal sign, it would give me the pH agad. 12.30. So 12.30. Laki, no? And let's put 70 here. Oops, sorry. So lagay natin 70. So yeah, it's 12.50. Oops, sorry. It's 12.52. Okay? So, yan. So, that's how you solve for the weak acid, strong base titration of the formic acid. Okay? So, kaya naman, di ba? As long as you just know the stages. So, now for this one, okay, I will leave this to you as an exercise. Pero may bibigay akong solutions for this one. So, sagutan nyo muna on your own. Then I will upload together with this video link yung answers dito sa part na to. Okay? So let's proceed to the next one. By the way, let's classify this one naman. Ito pala yung isa, sorry. Kamali ako ng ibibigay. Ayan. So, yun, nasagutan natin to. So, itong isa, sagutan nyo to. Ito yung nasa PowerPoint ata. Let me just confirm. Check natin. Well, yeah. Ito ngayon may answer na sa PowerPoint. So, sige, try nyo sagutan yan. Okay. Try nyo muna sagutan without looking at the PowerPoint. Then, check nyo if ito yung sagot nyo. If you got these answers, then that's a good work. Kung hindi, confirm nyo lang sa akin if may nagkamali kayo ng solving, plug-in, etc. Okay? Okay? So, yan. So, ito naman, kayo na rin magsagot na ito. Okay? Nasa PowerPoint din sagot dyan. Sagutan ko yung walang answer sa PowerPoint, such as this one. Okay? Pero let's classify this too. Okay? So, let's classify this and this. Ano kaya to? So, these are weak base strong acid. Okay? So, sodium cyanide. Cyanide is a base. No? Okay? HCl is an acid. No? Yan. So, yan. So, this is a weak base strong acid titration. So, try nyo gamitin yung equation sa weak base strong acid. And again, nasa PowerPoint yung sagot dyan. Pero solve nyo muna. Solve nyo muna. Ito yun. Ayan. Tignan nyo if you get this answer. Yung sasagutan ko yung walang sagot sa PowerPoint. Such as this one. Okay. I will try this one. Okay. So, basahin natin. 30 ml of 0.1 molar methylamine, CH3NH2, Kb 4.8 times 10 raised to negative 4, is titrated with 0.1 molar HCl. Okay. Ito, organic chem to. Yung mga amines, they are basic. Diba? Naalala nyo ba yun sa organic chemistry nyo? Pag amines, they are basic. So, this is base. This is an acid. So, yan ay weak base strong acid titration. So ito ay weak base analyte. Then this is your strong acid titrant. Okay? And now, just like the usual, ito yung inyong VA, MA, ito yung MT. Tapos ito yung VT. No? Ngayon, ang dami na naman volume binigay sa akin. Ang task ko is to identify anong stage to. So again, hanapin muna yung volume of titrant at the endpoint. No? So sulat natin ulit. At the endpoint, ano meron doon? The mole of the analyte is equal to the mole of the titrant. So MAVA equals MT VT. Just to distinguish this endpoint, lalagay ko EP, VTEP, volume titrant at equivalence point. So hanapin natin yung ating VTEP. So it's MAVA over MT equal sign. Let's plug in everything. So molarity analyte, volume analyte, and the molarity titrant. Kahit i-mental mo yan, ang sagot ay 30. So 30 ml is our equivalence point. No? Meaning ito ay post-equivalence point. Itong dalawa ay pre-equivalence point at ito ay initial. So ganun ka-important no, yung pag-identify ng stages sa titration curve. Pag hindi mo siya ma-identify, lost ka. Wala kang masasagot. So you should be able to solve first for the volume of titrant needed to reach equivalence point or the V time. Okay, so start lang yun. Now I will try to recall the equations. Okay. Pwedeng may kodigo kayo ngayon, pero ako i-recall ko siya. Wala lang. So initial, you begin with the base, no? So you begin with the base, so you get an OH. So ano lang yan, parang square root of tsaka, pero since ito ay base, yan ay CBKB. Okay? For the pre-equivalence point, this is the Henderson-Hasselbalch equation. No? So POH equals PKB plus log conjugate acid over the base. No? Okay, ayan. At equivalence point naman, meron dito, wala ka ng base. All you have is a conjugate acid. No? So makuha mo, H plus na. Okay. So wala ka ng base eh. Lahat yan conjugate acid na sila. So this is equal to the square root of the conjugate acid concentration. So yung BH plus conjugate acid yan parate ha. Times the Ka. And then at the post-equivalence point, mas malakas yung titrant kaysa sa conjugate acid. So excess titrant lang yung formula natin dyan. So MTBT minus MAVA over V total. Papansin nyo, regardless of the type of the titration, yung post-equivalence point equation ay pare-parehas lang. No? So pare-parehas lang MTBT minus MAVA over V total. Okay? So now, solve na tayo. Okay, so sige. Share with you my calculator. Okay, yan. So initial, you have your OH. Gagawin natin siyang pH. So paano ko ipa-plug in yun sa calcu? That will give me the pH na agad. So it will be 14 minus the POH. So it's negative log of that thing. Square root of CBKB. Ano yung concentration ng base? 0.1. Ano, KB 4.8 times 10 raised to negative 4. So when I press equal sign, pH na yung lalabas dito. Okay, so it's 11.84. Okay, so it's 11.84. So again, you should know paano na mag-type sa calcu, no? Na pag pinindot mo equal sign, pH agad lalabas. You have OH here. So na negative log mo siya, POH. Tapos isusubtract mo pa yun sa 14 pH. So 14 minus negative log of that thing. Okay? So that kaya na ha. Now, for the next part, pre-equivalence point. So gamit ulit tayo ng space sa baba. Okay? So gamit tayo space sa baba. So POH is equals to PKB plus log of the conjugate acid over base concentration. Okay. So ano yung pKb natin dito? It's the negative log of 4.8 times 10 minus 4 plus the logarithm of this thing. Saan galing yung conjugate acid? Galing yan sa titrant that you added. So it's MTBT. Ngayon, yung base natin, nabawasan yan. Kasi naglagay ka na ng titrant, di ba? Ang equation natin doon, MAVA minus MTBT. So, ano yung MT natin? 0.1. Ito, pa-plug in mo lang yan. O, yung MAVA, 0.1. Plus, ito ay 30. Tapos, ito ay 0.1 times X. Okay, so let's try yung 10 ml. Okay. So, POH to. Okay, POH yan. Ano gagawin mo para makuha mo yung pH? Subtract mo yan sa 14. So, 14 minus that entire thing. So, pKb, negative log of 4.8 times 10 raised to negative 4. Oops, sorry. Plus logarithm of the MTBT. Gawin ko yung 10 ml. So 0.1 times 10 divided by 0.1 times 30 na analyte minus 0.1 times 10. So answer is 10.98. Does it make sense? Yes. Bumababa yung pH. So 10.98. Okay. Now for the second one, okay, let's do the 15 ml. So 15 ml yung 10 palitan natin ng 15. Okay, so pretty straightforward. It's 10.68. Okay, so it's 10.68. Ano pa yung pwede natin ma-comment? Ano pa yung pwede natin ma-comment? Yung 15 ml is half of the 30. Okay? So, ano meaning nun? This is probably the pKa na rin, na? Okay? pKa is equal to the pH. No? Ayun. So, sige, pakita ko paano kinukuha yung pKa. Okay? So, 10.68 yung nasolve natin ng pH, di ba? Kunin muna natin yung pKb. Ang pKb niya is this, no? 4.8 times 10 raised to negative 4. Ayan yung pKb. Para makuha yung pKa, i-minus mo lang yan sa 14. So, 10.68 nga, no? So, yun yung special region. No? At half the endpoint, pH is equals to pKb. pKa. Or POH is equals to pKb. Okay? So, dun sila nag-i-equal. Okay, then let's proceed to the endpoint. Okay. So, the equivalence point, 30 ml. Sige. Dito na lang. Equivalence point, the square root of, H plus equal to the square root of concentration of the conjugate acid times Ka. So, saan galing yung conjugate acid? Sa titrant. But since this is equivalence point, pwede rin to sa amount of the analyte. No? Pero just to be consistent, I will use the titrant, MTBT, over V total. Then yung Ka, paano sinasolve? Kw over Kb lang yan. Okay? So if we take the negative log, it will give us the pH agad, no? Automatically. Let me just drag this sa gilid. Oops, sorry. So let's take the negative log of that. So empty, molarity titrant 0.1, volume titrant 30. Then for the volume total, gano'ng karami yung titrant? So you have 30 plus gano'ng karami yung analyte. Tingnan, 30 then. So you have 60 total volume na. Sorry, I forgot the square root pala. Square root, molarity titrant 0.1, volume titrant 30, over volume total 30 plus 30. 30 sa analyte, 30 sa titrant. Times, let's multiply this by the Ka, which can be calculated as the Kw. 1 times 10 raised to negative 14 divided by the Kb. That's 4.8 times 10 raised to negative 4. When I press equal sign, pH na yung lalabas. 5.99. And ano yung sabi ko kanina? Oops, nawala. So it's 5.99. So ano sabi ko kanina? The endpoint for the weak-base strong acid titration is less than 7. Why? Because of the influence of your conjugate acid. So siya kasi nag-i-influence sa pH ng solution. Kasi siya lang yung species na active at that point. And then finally, let's do that thing na. Finally, let's do the last one. Ito, diretso plug-in ko na sa calcu, ha? So, at the post-equivalence point, it's just the amount of the excess titrant. No? So, molarity titrant, volume titrant is 40 minus molarity analyte, volume analyte. Molarity analyte, volume analyte over the V total. So you have 40 titrant, 30 analyte. Total is 1.85. It's 1.85. Okay. Again, bakit wala na tayong equations ng equilibrium, buffer dyan? Kasi the strong titrant will overpower, no, the conjugate acid. So that's why ganyan lang equation. Okay, so there you have it. We have all the 4 types of the monoprotic acid-base titration. We have the strong acid, strong base, strong acid, weak acid, strong base, weak base, strong acid. Now, okay, so sa second part ng video na to, I will cover naman yung buffers. Now, it's just revisiting buffers. Okay, so I'll post the video and then we'll have the buffers. Okay, so we're back and let's try to answer some of the buffer equations that we had last time. Well, this is just a review lang naman ulit. Okay, so babalikan lang natin just to strengthen your knowledge of buffers. So again, sabi natin that if you have a buffer system, ano yan? If you have a buffer system, yan ay composed of a conjugate acid base pair or a base conjugate, or a conjugate base acid pair na. Okay. And they try to resist the change in the pH of the solution. May mali dito sa equation na to. Ito yun. Sorry. So this should be POH equals PKB plus log BH plus over B. Okay. So sorry, kalimutan ko baguhin. Okay, so that's buffers. Okay, Ayan, and balikan lang natin yung mga some of the basic equations na kailangan natin isabuhay. For example, this one, okay? So, sodium hypochlorite, NaOCl, the active ingredients of almost all bleaches, was dissolved in a solution buffered to pH 6.2. What is the ratio of OCl, HOCl in this solution? Right? So, solve natin. No? Buffer to. No? So, lagay natin pH equals pKa plus log. Ano yung acid dito? OCl, di ba? HOCl. Hypochlorous acid and the hypochlorite an ion. Okay? Yan. So, itong 6.2, this is the pH na to. Yan yung pH. Paano kung hindi given yung pKa? Well, di ba may sa lab manual, bandang dulo, you have a list of the Ka values. So, nung tinignan ko yung list of Ka values, well, ang Ka for the HOCl, okay, ito galing to dun sa sa table. So, sabi doon, it's 3 times 10 raised to negative 8. Okay? So, yan. So, given all that, ang sinahanap sa atin itong ratio na to, no? So, that's inside the logarithm. Okay? That means, gusto natin siya tanggalin sa logarithm. How will we do that? We do the anti-logarithm, no? So, lipat natin yung iba doon sa left side. So, pH minus pKa equals log of OCl, HOCl. And then, since nasa log to ng logarithm, mag-anti-log tayo. So again, how do you do the anti-log? You make everything an exponent of 10. So that means 10 raised to pH minus pKa is equals to the ratio itself. Okay, so yun na mismo yung mas kikita natin. So what's the pH? Well, pH is, sabi dito, 6.2. What's the pKa? So yun, 3 times 10 raised to negative 8. So i-negative log na natin dito. No? So na-negative log ko na siya kanina. And ang sagot ay 7.52. So when you take this value, ang lalabas dyan ay 0.0479. So that's the ratio of the OCl and the HOCl. Now, what does it mean? So what it means na the OCl concentration is 0.0479 and the HOCl concentration is 1. Okay, so you can think of it that way. Yung mahonyong ratio, it's always divided by 1. So yung nasa numerator that corresponds to this, nasa denominator that corresponds to this. Okay, so always 1 yung nasa denominator. Okay. So those are their molarities or pwede rin moles. Those are their moles. Right? Let's try to answer another problem. Okay, so ito naman, find the pH of 1 liter aqueous solution prepared with 12.43 grams of tris. The formal mass is 121.135, which is smaller mass lang din. And 4.67 grams of tris hydrochloride. So 596 grams per mole. Okay. So yan. So what do we know about tris? No? Tris is a buffer na ginagamit yan sa biology. So kunwari, you're isolating proteins. Ayan, tris yung ginagamit. And sa base, no? Okay, so base yan. Kasi itong katabi niya, acidic yan. Hydrochloride eh. So this is your base. Probably this is your conjugate acid. No? Sa tris hydrochloride. So the appropriate equation for this one is yung base na Henderson-Hasselbalch. No? By the way, ibibigay naman namin sa inyo yung identity ng compound mismo. This one nakalimutan lang namin i-add. No? So base yung tris. So nasa baba siya. And then yung tris hydrochloride nasa taas. No? Tris HCl. So saan ginagamit yung tris? Sa buffer yan ng proteins. No? Ginagamit yan sa biochem. Ako hindi ko nagamit yan kasi ayoko ng biochem. Okay. And now, well, you have to Google for the value of tris. No? Wala siya sa table eh. Pero ako na-Google ko na siya. And according to Google, the pKb of tris, pKb na yung nakuha ko eh, is 5.928. No? So 5.928. So yun ay ipa-plug in ko dito. So yan yung sabi ng Google. No? 928 plus logarithm of this amounts. Ganito. Di ba nasanay tayo puro molarity? Pwede rin naman moles. No? Okay, pwede rin moles yung nandyan sa Henderson-Hasselbalch equation. And yun yung ginagawa natin since kanina pa, di ba? Yung MAVA, MTVT, puro moles yun. So, paano naman kapag solid? Pwede pa rin. Okay. Just remember lang na kapag solid, the moles can be calculated as mass over molar mass. Okay? So yun na, baka kasi hanapin nyo, asan yung MAVA, asan yung moles, molarity, volume? Wala, kasi solid yan eh. So pwede pa rin naman. Okay? So to get the moles of the tris HCl, so again, moles yung gagawin natin. It's just the mass of the tris HCl over its molar mass. No? So 4.67 divided by 157.596. No? Then for the tris, so 12.43 grams yon. So 12.43 grams divided by 121.135. So when you calculate for all of this, sa calculate nyo, lalabas is 5.39. And if you get the pH, it's 8.61. Okay, so that's the pH of the tris buffer. So, I'm not sure, di pa kayo siguro nakita ng buffer na powder. No? Siguro pakita ko sa inyo. Punta tayo sa internet. Okay. Tignan nyo ta. Ayan. So parang ganito yung sa tris din na. Ayan. Ayan. So this buffer powder, combination na siya ng acid conjugate base, base conjugate acid. So magkahalo na yan. Tapos nakasabi na dyan kung saan mo siya i-dissolve sa 250 ml ba, sa 1 liter, etc. Okay? So when you put that, no, pH 4 agad siya. Okay? So parang ganun yung concept doon sa last problem natin. No? May dalawang mass ka ng different compounds. Pag hinalo mo yon, may certain pH na siya. Ayan. Okay? Share ko lang. Pabalik na tayo. Okay. Now, balikan daw natin yung problem. Sabi dito, if we add 12 ml of 0.1 molar HCl to the previous example, what will be the new pH? Kopyahin ko lang yan nandito sa previous problem natin. So siguro ito na lang kopyahin natin. Ayan. Nasulat ko na kasi yung solution sa papel ko dito, kaya nalingon ako dito. Okay, so ano sabi natin dito? This is 5.928 plus logarithm of their moles. Na? So yung 3HCl, ano yung expression natin doon kanina? 4.67 divided by 157.596. Ang tris naman ay 12.43 divided by 121,135. So yan yung original. However, look, you are adding acid. You are adding HCl. So what will happen? Sino yung dadami dito? Is it the tris or is it the HCl? Yung acid. Adi syempre yung acid na. Yan na, HCl na nga eh. So dadami to, mababawasan to. So in terms of equation, we can write it as this moles plus the mole of the HCl that you're going to add. Kasi dito naman sa baba, it's minus the mole of the HCl that you are going to add. No? Parang yun sa ano lang, pre-lab nyo sa experiment number 4. No? You're adding acid, so tataas to, bababa yung isa. But keep in mind, moles to ha, moles to. Molarity times ml, millimoles yon. So dapat ito gagawin nating liters para maging moles din. So moles to, that moles din yan. Yung last time lang, di natin ginaganon kasi puro volume, puro millimoles yung nasusolve natin. But this time, ito ay moles. So hindi pwede i-subtract yung millimoles sa moles. So how do you get the moles of the HCl? So it's 1 0 mole per liter. And then, yung 12 ml, it can be written as 0.012 liter. Okay? So again, keep in mind, dapat moles yung makukuha natin. Okay? So mole. Yung sa mga solving natin kanina, millimoles lahat yon. Okay? When you have molarity times ml, millimoles yon. And then when you divide it by ml, magiging molarity ulit yan. Okay? So, ayan. But this time, kailangan moles talaga kasi mass over molar mass is moles. So, hindi pwede ml yung gamitin mo dito. It should be liters para maging mole yan. So, when you plug that in the calculator, nagawa ko na siya kanina. So, when you plug that in, lalabas ay 5.59 pOH or the pH is 8.41. Now, does it make sense? No? Does this make sense? Yes. No? Kasi kanina, without the HCl added, the pH was 8.61. However, upon adding your HCl, mas lalo siya bumaba, 8.41. So, it does make sense. Okay, so let's now go dito sa problem na to. This problem is quite hard na. Medyo mahirap ta. Okay. So how many ml of 0.5 molar NaO should be added to 10 grams of 3-hydrochloride to give a pH of 7.60 in a final volume of 250 ml? So we don't care about the final volume anyway. Okay. So yan. So sige. So ito yung ating problem na. This is not related to the previous problem except that we have to get that the pKb of tris is ano yan? 5. 928 na. So 5.928 na. So hindi siya related sa sinode natin kanina. So Tagalogin ko yung problem. Meron ka lang tris HCl powder. Wala kang tris. So tris HCl powder lang. Okay? Tapos bubuhusan mo daw siya ng base para maging 7.6 yung final pH. Ang tanong, gaano karami yung base? Okay? So, tris HCl powder lang meron ka. Wala kang tris HCl lang meron. So, paano yun? Let's write the Henderson-Hasselbalch equation. So, base yan. So, POH equals pKb plus log conjugate base. Conjugate acid over base. No? Okay? So, again, wala ka nito. So, tris HCl lang meron ka. But, mag-a-add ka ng NaO. No? So, what will happen? Now, what will happen? When you add NaO, your conjugate acid will be returned, okay, will be converted again to the base. No? So, mababawasan to. Okay? Kasi, base yung ilalagay mo. Tapos, dadami to. No? Now, since, again, wala ka nga neto, the amount of the tris that you will have in your final solution is related to how much base will be added, no? So yung dami ng tris na meron ka, related yung kung gaano karami to. Okay? So we can write here tris from NaO. Okay? So wala kasi tayong tris powder. Pero magkaka-tris ka when you added NaO. And what else do we know? Ang HCl, mababawasan yan. No? So mababawasan yung HCl ng dami ng NaO added. Okay? So diyan iikot yung ating equation. So ano yung final POH? So binigay kasi pH 7.6. So if you get the POH, that will be 6.4 na. Okay? So 6.40, ayan yung POH. PKB yun na yun, 5.928 plus logarithm. Okay? So ulit, ano yung dami ng tris mo in moles? So that will be 10 grams of tris HCl divided by its molar mass. 157 point, ano yun? 596. So moles minus the added NaO. Molarity times volume yan. No? So you have 0.5 molar times X volume in liters para maging moles. No? So ganun din sa baba. Because yung tris natin, that will come from the NaO added. So yan, so you have an X. So nagagawin mo, we solve for the value of X. Okay, so let's solve for the value of X. So let's simplify this equation. So 6.40 minus 5.928 equals log of ano ba tong fraction na to? Solve ko nga. So 10 divided by 157,596. So mag-round off na lang ako . So pag nag-round off ako, this will be 0.06345. Ayan. Minus 0.5 minus x na. 0.5 times x pala. Okay. Tapos i-subtract ko to. So just simplify everything. So 6.4 minus 5.928. So this will be 0.472. of that thing. Now, you can solve for x na. Pwede ka na mag-shift solve. Or pwede rin naman ikaw mag-anti-log. So ako i-anti-log ko na lang, ha? Okay. So let's take the anti-log of both sides. So you have 10 raised to 0.472 equals the fraction 0.06345 minus 0.5x. Then this is 0.5x. Okay. And then let's solve for x na. So if we solve for x, yan, dito na lang ako mag-shift solve kasi mas kaya na to ng calculus ng mabilisan. Okay? So that's let me share you my phone na lang. Okay. So let's solve for x. Okay. So bakit ko sinimplify siya? Kasi if i-plug in ko to as is, yung buong equation, matatagalan yung calculus na. Baka mag-error pa yan. So that's why I tried to simplify things muna. Ito, subtract mo lang naman. Ito, di-divide mo lang naman. So yung log, in-antilog ko lang. Okay? So mas madali na siya isolve ng calculus. Kasi pag hindi mo sinimplify, minsan tatagal lalo yung calculus. So yan, let's solve for x. So it's 10 raised to 0.472 equal sign 0.06345 times 0.5x divided by 0.5x. And then we can shift solve. No? So shift solve equal sign. Minus pala, sorry. Diba? So 0.06345 minus 0.5x. So let's press shift solve. Ayan. So yun yung sagot. So x is equals to 0.032. Or liters yan eh. Kasi molarity times volume in liters yan. If you want to make it ml, you multiply it by 1,000. So it's 32 ml. So ganyan karaming nao kailangan i-add mo sa 10 grams of the 3HCl para yung final pH niya ay 7.6. Sige nga, try ko i-shift solve itong ano. Hindi ko pa siya na-try kasi manual solving ko. So try ko i-plug into dito sa calculus kung kaya. So 6.4. Try lang natin. Curious din ako. 928. Kasi baka mag-error kapag diniretso mo. Tignan natin. Hindi ko pa siya na-try. Okay, shift solve. Kaya naman pala. Pakahirap pa tayo. Well, it depends on your calculator. Pero kaya pala. Okay? So, kaya pala ito i-shift solve. Pakahirap pa ako. No? Okay, so those are the questions related to buffer. Okay, so now, last part na to. Thank you, Lord. So, halos 2 hours na rin yung recording natin. So, in this last part, discuss natin how indicators are selected no, in titration processes. No? Okay. Important dito sa indicator yung endpoint ng iyong analyte. Okay. So, important yun. No? Kasi kunwari, strong acid, strong base titration or weak acid, strong base titration, pwede mo gamitin yung phenolphthalein. Pero paano kung weak base, strong acid titration? Hindi pwede gamitin phenolphthalein. Rather, we use a different indicator for that. That's bromocresol green or methyl orange. No? So it depends, no? It depends kung anong type yung analyte mo sa type of indicator na pipiliin mo. Okay? So in this chart here, in this table here, ito yung mga indicators, and then these are the pH ranges, and ito yung kanilang colors. So we have a good graph here showing the range of the pH, and the color change. No? Okay. So ganito, bigyan ko kayo context. If you have a strong acid, strong base titration, acid yung analyte, base yung titration, ano yung mga pwede mo gamiting indicator? So, indicators that are near pH 7. So actually, pwede pala yung nitrophenol, pwede pala yung orthocresol, pwede yung phenolphthalein, kasi malapit siya dito sa 7. Okay? Pero yung mga beyond 10, hindi na pwede yan. Okay. Why is that? Bakit limited lang tayo dito sa malapit sa 6 to 9? Bakit ang ganun lang? Kasi remember, for a strong acid, strong base titration, yung inflection point niya mahaba, no? So, pwede ito, kunwari, pH 3, 7, dito, 11 na agad yan, or 10, no? So, mahaba kasi, inflection point niya. Therefore, it will pass several color changes ng indicator. Okay? So, it may pass several color changes sa indicator. So, that's why for a strong acid, strong base titration, medyo malawak yung scope. No? But again, the endpoint is around 7. So, pipili ka ng indicators that are here sa 7 beyond. No? So, ano yung mga indicators na pwede? Pwede bromothymol, pwede phenol red, methyan, orthocresol, phenolphthalein, thymolphthalein. Yan yung mga pwede for a strong acid, strong base titration. Okay. Now, paano naman kapag strong base, strong acid titration? So, pag ganun yan, di ba? So, well, around this pa rin. No? Okay. Pero, what you want to do is yung pH below 7 na. Okay? Kasi acidic na yung pH mo dito eh. No? Okay. So, you want to choose yung mga indicators that will change color about below 7 na. So, ano yung mga pwede doon? So, pwede bromothymol blue, aerochrome, methyl, alizarin, bromocresol green, and pwede rin yung methyl orange actually. No? So, you want to choose yung indicators that will change colors before siya mag-excess, no? Before siya maging excess titrant na, or before siya maging super acidic, no? So ganun yung dynamics when choosing an indicator. You choose an indicator which will change color, okay, just in the right time when your analyte is being fully converted into products, no? And then yung range ng pH, no, ng color change should be either greater than 7 for strong acid, strong base, or less than 7 for strong base, strong acid. So again, these are applicable. So itong mga indicators na to, these are applicable for strong acid, strong base titration. Your analyte is an acid, base is the titrant. Pero these things here, yan ay pwede sa strong base, strong base, strong acid titration. Okay? So yan. So ganun lang yung idea dyan. Paano naman kapag weak na? No? If you have a weak. Okay. Paano kapag may weak weak acid, strong base na? So di ba pag ganun yung niyan? So your pH is greater than 7 at the endpoint. So you may want to choose indicators that will change color past 7. No? So around dito na yung pwede mo piliin. So it could be the phenolphthalein pa rin, the orthocresol, the thymol, phenol, the alizarin yellow. No? So yan. Pwede rin itong meta-nitrophenol. So you want to choose an indicator that will change color beyond 7. No? So ito na yan. Okay, so ito yung mga okay for WASB titration. How about the ano naman, the weak base strong acid? So ganito yung graph nun eh. Okay, the pH at endpoint is ano, less than 7 at endpoint. So you might want to choose pH na below 7. So probably around 6. No? So ayun, around dyan. No? So ito yung mga pwede for WBSA titration. Okay. Pero ano ba yung ginagamit talaga? No? Parang ang dami. Well, ang ginagamit talaga in actual labs ay ito lang. So phenolphthalein, okay yan. Yan, that's okay for ano, strong acid, strong base, weak acid, strong base titration. Okay yung phenolphthalein. Ginagamit din namin yung methyl orange. This is for strong base, strong acid, and weak base, strong acid. Ganon din yung bromocresol green. Ginagamit din yan sa SBSA, WBSA. Yan yung mga personally na gamit ko. Ayun. So, yan lang naman. So, either methyl orange, bromocresol green, phenolphthalein, and yellow. Okay. So, ano yung pinaka-point ko dito? Ang pinaka-point ko dito is that you choose an indicator that will change color when you are about that pH, no? Na mag-endpoint na siya, no? And gusto mo, that yung color change will surpass near the endpoint, near the post-equivalence point, no? Okay. Kasi kapag yung pH change niya is below the post-equivalence point. Kunwari, ito yung post-equivalence point, pH 10, tapos pinili mo ito, aerochrome. So, puro blue na lang yan. Di mo na ma-distinguish kung ano yung post-equivalence point. Unlike when you choose this, pag nasa equivalence point ka, pink yung phenolphthalein, pero at the post-equivalence point, kulay red na siya. Okay? So, you want to choose an indicator that will start changing color at the endpoint and to the post endpoint. No? So, hindi pwede gamitin yung ito. Hindi mo pwede gamitin dinitrophenol. Dilaw na yan all throughout. No? Hindi mo pwede gamitin erythrocin B. Orange na yan lahat and so on. No? So, you want to choose an indicator that will change color, no? A little past the endpoint. No? Para intense yung color. Similar to the strong base strong acid, no, or the weak base strong acid titration. You don't want an indicator that will change color dito. Kunwari pH 9, nag-phenolphthalein ka. Strong base strong acid. Ang post equivalence andito sa left side, no? So puro clear na yan, di mo na ma-distinguish kung lumagpas ka na talaga, no? So you might want to choose somewhere banda dito sa region na to para alam mo na nakapag-post na, iba na talaga color niyan. From blue, naging green, endpoint na yan. Pag nag-yellow, lagpas ka na. Yung orange, pag naging, yung yellow, pag naging orange, endpoint na yan, lagpas ka na. Yung blue, naging yellow, lagpas ka na. So, these are, yun yung selection ng indicator. Ganun. What else? What affects the endpoint na what affects the selection of the endpoint? The concentration of your acids, no, and the bases. If you have a very high concentration of the analyte and the titrant, no, your inflection curve will be very long. Kapag super laki ng concentrations nila, mahaba yung inflection point. Therefore, you have several options to choose from. Pwede phenolphthalein, pwede bromothymol, pwede bromocresol. But when you have a very low concentration of your analyte and the titan, kung mababa yung concentrations nila, lumiliit yung inflection point. So instead of using these three indicators equally, ang pwede na lang is ito, the bromothymol, yun sa dashed line. No? Okay? So ito, pre-equivalence pa yan. Ito, post na yan. So ito lang yung papasok sa equivalence point ni dashed line. So again, the higher the concentration, the longer the inflection point. So the lower the concentration, the shorter the inflection point. Therefore, the shorter the range of indicators that you can use. Mas onti yung pwede mo gamitin. So ito din yung sinasabi ko kanina. So sa weak acid strong base titration, okay? Pwede yung phenolphthalein, pwede bromothymol, pero hindi pwede yung bromocresol. Why? Kasi yung transition niya is below the endpoint or the post-equivalence point. So you cannot choose this. Okay? Ganon din sa weak base strong acid, no? Okay? So, yan. Ayan. So, bali ganun lang. So, the selection of indicators, no? Well, ito naman sinasabi lang dito is the effect of Ka, no? So, the greater the Ka, the longer the inflection point, no? Okay? Same as the base, no? The greater the Kb, the stronger the inflection point. Kapag mababa yung Kb, maliit lang yung inflection point. Therefore, you have a very few selection of indicator to choose from. Okay. So, ganun lang. So, those are the things you have to keep in mind na when you choose an indicator, number one, make sure it passes through the equivalence point pH and it can distinguish the post-equivalence point. Yun lang yung dalawang rules when selecting indicators. And then concentration goes up, the inflection point becomes bigger. Therefore, you have a wide variety of indicators to choose from. Pero kapag bumababa yung concentration, so maliit yung inflection point, therefore you have a smaller choices for the indicators. In terms of weak acids and weak bases, the Ka can also influence the length of the inflection point. No? So the greater the Ka, the longer the inflection point, the greater the Kb, the longer the inflection point as well. Okay? So that ends chapter 5, no? So siguro sa susunod natin pagkikita chapter 6 tayo, no? But on Thursday, tignan natin if we can do that. Okay, so that's all for today. I'll see you again on Thursday.